And for the final thing we need to just check is to be able to do worded questions in linear algebra, linear graphs. To be able to understand how to do these application type questions, it's so important. So here's an example. I'm just going to jump straight into an example. Mr. Heaton has 28 students at the start of a class, but only 25 left after 5 minutes. So they're probably leaving because they're bored and that sort of thing. It's a horrible topic, linear graphs. So they're just leaving in that way. If the students leave the class in a linear fashion, in other words, it's a straight line graph, it's a linear graph, find the equation and use the equation to predict when he will have no students left. Okay, so let's just have a look at this. What's the important information? I might just underline some important information in here. Firstly, he has 28 students at the start of the class. Then he has 25 students after 5 minutes. So that's the second sort of piece of key information. And thirdly, they're leaving in a linear fashion. Okay. In other words, it's a constant linear fashion. We need to find the equation. Okay. It's good to start with defining some variables because without that we're sort of lost. Okay. So what we're going to say is let y be the number of students left in the classroom. Left in the classroom. Okay, so y will be the number of students left in the classroom. Okay, it's really important to say what y is and what x is. And we're going to let x be the number of minutes. Number of minutes, I guess, since the class started. Okay, so they're my two variables. And they're the two variables I'm going to develop our linear equation around. Okay, now that we've done that, we can sort of develop some points. And I'll show you what I mean. We've got these points. We see here that we've got 28 students when? We've got 28 students at the start of the class. In other words, after 0 minutes, we have 28 students. How do we write that? Remember, x, y are our points. And so what we've got is when time is equal to 0, in other words, since there was 0 minutes of the class, after 0 minutes, we have y, 28 students. In other words, when there's 0 minutes, we have 28 students. Also, we've got 25 students after 5 minutes. So that means when x is equal to 5, so after 5 minutes, we have 25 students left. And so we've got these 2 points. And if you remember from determining equations, if you know 2 points on a linear graph, and we've got a linear graph we know because we were told it was linear, then we can figure out the equation of the line. How do we do that? Let's go. Let's have a crack at this. So what we've got here is we've got 2 points. Let's label these x1, y1, and x2, y2. And let's have a look at it. How do we find the equation of the line? Well, we need to firstly find the gradient. So let's do that. How do we find the gradient? Our gradient m is equal to y2 minus y1 over x2 minus x1. And what is this equal to? y2 is 25, y1 is 28, x2 is 5, x1 is 0. And so 25 minus 28 is negative 3, 5 minus 0 is 5. And so we get our gradient of negative 3/5, or negative 0.6 if you put that into your calculator. Okay, so there's your gradient. What was the next step? If you remember back from the determining equations videos, what we need to do now is find c. Okay, so I've got y equals mx plus c, and we just figured out that m was equal to negative 3/5. So y equals negative 3/5 x plus c. There's our equation so far. The next piece of the puzzle, we need to figure out c. And what we need to do, if you remember, is because this equation governs every point on the line, and we know that these 2 points are on the line, all we need to do is substitute one of these points. It does not matter which point you choose, you should get the same answer. Okay, so substitute one of these 2 into there and you'll get the answer. So let's do that. So sub, and I'm going to choose this point here. Because it's got a 0 in it, it means that the maths will be easier. And so let's just do, I'm going to sub 0, 28 into our equation. Therefore, right, our equation is y equals negative 3/5 x plus c. What was the y value? So we got 28 should be equal to negative 3/5 times by the x value. What's the x value? 0. And you can see why I chose that, because negative 3/5 times 0, it's 0. Nice, easy. If you did that, you still get something, but this just makes the maths a bit easy. Plus c. Negative 3/5 x, that's just 0, that disappears. And so therefore we get 28 equals c, c equals 28. Now, I just want to show you something. We just got that the y-intercept is equal to 28. Remember what the y-intercept means? The y-intercept is when x is equal to 0. What is x in our example here? X is equal to the minutes since the class started. X is equal to 0 means where the class started. So our y-intercept is just the number of students when the class started. We already knew that that was equal to 28. That number is up here. So if you knew that, you could have actually used that point to go, well, that is just c. So if you're clever, you can do that. So this means that the equation is y equals mx plus c, so negative 3/5 x plus c. C was 28, so plus 28. That is the equation of the line. We're not done yet. We're supposed to find the equation, but we want to use this equation, so we're modelling this situation. We want to use it to predict when Mr. Heaton will have no students left. What does that mean? We want the number of students to be equal to 0. So that is y. So I'm going to have to go to a new page, but what we're doing is we want y to be equal to 0. The number of students in the class to be equal to 0. So just got to remember that. Negative 3/5 x plus 28. Y equals negative 3/5 x plus 28. Okay, that was our equation. What we want is we want to know when the number of students when the number of students equals 0. Equals 0. In other words, we want to know when y is equal to 0. So, what we do is we use this equation and we substitute in y is equal to 0. So therefore 0 equals negative 3/5 x plus 28. And we just solve this for x. So therefore, I'm going to move all this, I'm going to just switch sides actually. I'll go negative 3/5 x plus 28 equals 0, just to make it helpful for me. Negative 3/5 x equals negative 28. I've moved that positive 28 to the other side, so negative 28. I'll get rid of the negatives on both sides. In other words, I'll times both sides by negative 1 to sort of change the sign. I'll times both sides by 5, so therefore 3x equals 28 times 5 is 140. Did I get that right? 20 times 5 is 100. 8 times 5 is yes. And so therefore, I'll divide both sides by 3. That's equal to 140 divided by 3, which is, drum roll, can I do it in my head? Well, 120 would be 40 minutes. And so, well, 130, no, 39 will be 13 plus, so after 100, sorry, I should, can I just cheat, sorry, 3, 0, 4 times, remainder 2, and then that'll go 6 times, remainder 2, yeah, 6, okay, so that's 46.66. Okay, and so what this means, what was x again? X told us the number of minutes since class started, and therefore a good answer would be after 46.66 minutes the whole class is left. Because it's just boring maths, isn't that right? And so that's an example of how you use linear graphs to model a certain situation. We're modelling it, and then how you use those models to try to find things. So you could also ask, how many students are left after 20 minutes or something like that. You can do a whole bunch of things, and you could sketch that equation to see what it looks like. It's a very, very powerful tool. But I'll leave it at that. Hopefully you understand that. Have heaps of practice with applications.